blood is important connective tissue which flows between the different parts of the body and maintains the physiological processes of our body. At the time of injury, blood loses its fluidity and converts to a semi-solid jelly called clot by the process of clotting of blood or coagulation. This phenomenon to prevent blood loss is known as hemostasis, is mediated by vascular, platelet and plasma factors. Coagulation or blood clotting is of enormous physiological importance as it prevents further hemorrhage. Efficient control of bleeding occurs through a complex process called hemostasis, which includes 4 basic steps of blood clotting processes, which are vasoconstriction, platelet activation, thrombus formation and dissolution of the clot. Vasoconstriction is the term used to describe tightening of the muscle in the blood vessel wall. When an injury occurs, nerves in the tissue surrounding the blood vessel stimulate the muscle of the blood vessel wall to constrict, narrowing the lumen of the vessel, thereby temporarily restricting the flow of blood from the wound. Initial vasoconstriction lasts only about a minute, but then a secondary mechanism starts which involves release of chemicals such as serotonin and epinephrine from blood cells called platelets that have started to gather at the site of the injury. Platelets continue to stimulate the nerves, which causes contraction of the muscle of the vessel for several more minutes. Platelet activation. 2 substances, fibrinogen found in collagen and prothrombin found on the surface of the platelets are activated. Platelets or thrombocytes begin to adhere to the exposed collagen. This step is called platelet activation or platelet aggregation. As the platelets begin to assemble at the site of the injury, several factors are released from the platelets. Thrombus formation. A more stable clot called a thrombus must form to make a longer lasting seal on larger injured blood vessels. The thrombus must be able to maintain a seal on the damaged blood vessel wall, especially that of an artery where the blood pressure is higher than in a vein, even after the blood vessel walls are no longer constricted. At the time of injury or surgical cut, a series of biochemical reactions leads to the formation of a blood clot within few seconds, and the bleeding vessel is plugged off by the clot. The renunciation of clot compresses the ruptured vessel further and bleeding stops. Coagulation of blood is a complicated process in which about 13 coagulation factors are involved. All these factors are blood proteins or their derivatives. Factors involved in blood clotting are Factor I, fibrinogen, Factor II, prothrombin, Factor III, thromboplastin, Factor IV, calcium, Factor V, proacceleratin, also called labile factor and accelerator globulin ACG, Factor VI, acceleratin, Factor VII, proconvertin or stable factor, Factor VIII, antihemophilic factor A, Factor IX, antihemophilic factor B, also called Christmas factor, Factor X, Stewart-Prower factor, Factor XI, antihemophilic factor C, also called plasma thromboplastin antecedent PTA. Factor 12, Hagman factor. Factor 13, fibrinase, also called as fibrin stabilizing factor FSF, and Laurent factor LLF. Clotting mechanism begins by formation of prothrombin activator, which causes conversion of prothrombin into thrombin. There are two pathways of formation of prothrombin activator, intrinsic and extrinsic pathways. This reaction leads to the activation of thrombin enzyme from inactive form prothrombin. Thrombin will change fibrinogen plasma protein into fibrin insoluble protein. In both the extrinsic and intrinsic pathways, a series of different plasma proteins called blood clotting factors play major roles. Most of these are inactive forms of proteolytic enzymes. When converted to the active forms, their enzymatic actions cause the successive reactions of the clotting process. Most of the clotting factors are designated by Roman numerals. To indicate the activated form of the factor, a small letter A is added after the Roman numeral, such as factor 8A, to indicate the activated state of factor 8. It is triggered by a chemical called tissue factor that is released by damaged cells. This pathway is extrinsic because it is initiated by a factor outside the blood vessels. It is also known as the tissue factor pathway. This leads to the following steps: release of tissue factor. Traumatized tissue releases a complex of several factors called tissue factor or tissue thromboplastin. This factor functions mainly as a proteolytic enzyme. Activation of factor 10. The lipoprotein complex of tissue factor further complexes with blood coagulation factor 7 and in the presence of calcium ions acts enzymatically on factor 10 to form activated factor 10, 10A. Effect of activated factor 10, 10A to form prothrombin activator. The activated factor 10 combines immediately with tissue phospholipids that are part of tissue factor or with additional phospholipids released from platelets as well as with factor 5 to form the complex called prothrombin activator. Within a few seconds, in the presence of calcium ions, this splits prothrombin to form thrombin. It is triggered by blood coming into contact with collagen fibers in the broken wall of the blood vessel. It is intrinsic because it is initiated by a factor inside the blood vessel. It is sometimes called the contact activation pathway. This leads to the following steps: activation of factor 12 and release of platelet phospholipids. Trauma to the blood or exposure of the blood to vascular wall collagen alters two important clotting factors in the blood, factor 12 and the platelets. This converts factor 12 into a proteolytic enzyme called activated factor 12. Simultaneous release of platelet phospholipids that contain the lipoprotein called platelet factor III also plays a role in subsequent clotting reactions. Activation of factor XI. The activated factor XII acts enzymatically on factor XI to activate this factor as well, which is the second step in the intrinsic pathway. This reaction also requires HMW, high molecular weight kininogen, and is accelerated by prekallikrein. Activation of factor IX by activated factor XI. The activated factor XI then acts enzymatically on factor IX to activate this factor also. Activation of factor X. The activated factor IX acting in concert with activated factor VIII and with the platelet phospholipids and factor III from the traumatized platelets activates factor X. Factor VIII is the factor that is missing in a person who has classic hemophilia, for which reason it is called antihemophilic factor. Platelets or thrombocytes are the clotting factor that are relatively decreased in the bleeding disease called thrombocytopenia. Action of factor Xa to form prothrombin activator. This step in the intrinsic pathway is the same as the last step in the extrinsic pathway. That is, activated factor X combines with factor V and platelet or tissue phospholipids to form the complex called prothrombin activator. The prothrombin activator in turn initiates within seconds the cleavage of prothrombin to form thrombin. Both pathways eventually produce a prothrombin activator. The prothrombin activator triggers the common pathway in which the prothrombin becomes thrombin, followed by the conversion of fibrinogen to fibrin. Prothrombin in its active form is referred to as factor IIa thrombin. Several substances including thromboplastin, factor III, calcium and vitamin K play a role in the activation of prothrombin to thrombin. Thrombin in turn helps to convert fibrinogen factor I to fibrin factor Ia. Fibrin is an insoluble protein that, when it reacts with other substances, polymerizes to form strands that web together to form the basis of the thrombus. Web of fibrin is referred to as fibrin mesh. Factor XIII fibrinase is activated to serve as additional stabilization of the fibrin mesh. A more stable clot called a thrombus must form to make a longer lasting seal on larger injured blood vessels. Fortunately, the clotting process is self-limiting. Substances called antithrombins prevent the clot from continuing to enlarge, otherwise the established clot would block the flow of blood within the vessel. Dissolution of clot, also called fibrinolysis, occurs when a negative feedback system signals that sufficient healing of the blood vessel wall has occurred and a substance called plasminogen is activated. Plasminogen in its active form is called plasmin. Plasmin signals the clotting mechanism to inactivate the procoagulant clotting process and begins the anticoagulant process with the use of naturally occurring heparin. It is achieved by digesting the fibrin, which is the main component of the thrombus. The body then returns to its state of balance called homeostasis. Bleeding disorders. Bleeding disorders may be due to following reasons: lack of fibrinogen, dissolution of prothrombin, lack of antihemophilic factor, due to diminution of factor V, VII, IX and XI, thrombocytopenia and vitamin K deficiency. Coming to the conclusion, blood helps different parts of the body to perform all physiological processes with the dissolved nutrients and oxygen. Bleeding should stop timely to prevent further hemorrhage and eventually death. In some cases, blood clots form too easily or do not dissolve properly and travel through the body, limiting or blocking blood flow. This also can be very dangerous. Bleeding disorders may arise due to lack of fibrinogen, dissolution of prothrombin, lack of antihemophilic factor, diminution of factor V, VII, IX and XI, thrombocytopenia and vitamin K deficiency.